Alright, so I wanted to make a little video to review what we talked about the last couple days with electrons. So this is taking what you may have already known and just sort of adding a layer to that. So our Bohr model of an atom is drawn in shells. So typically when we have talked about this before, we look at something that looks like this. So this would be an atom drawing with 4 electron shells. This one over here with the subshells, this is just looking into that more in depth. So each of these shells we had looked at before are the main shells, and then those are broken up further into these subshells. And each of those subshells can hold a certain amount of electrons. So this is something that you looked at with your chart. So the very first shell we have is the smallest, and it's called the S subshell. And that can hold a maximum of 2 electrons. So for the very first shell in an atom, that very inside one, it only has that S subshell, so that's why it can only hold 2 altogether. The next one out, the second main shell, which is this one here, it has an S shell as well as P subshells, which can hold a total of 6 electrons, and that gives us our 8, which you may recognize from our octet rule. Going out to the third main shell, we now add a D subshell, and that can hold 10 altogether. So that's why that third shell can sometimes hold up to 18. But that's also why it won't always be the case, but just for our larger elements. And then when you get out to the next step, that fourth main shell, we add an F subshell, which can hold up to 14. So that's why that fourth one can go up to 32. So writing the electron configurations then, which we also looked at, this periodic table breaks it down nicely. So you can see that the elements on this side, this will be considered the S block. The middle one here in the transition metals is considered the P block, and then your P and your F. So you can really easily figure out your electron configuration, which is just a way to abbreviate what the drawing would have been if we drew out the electrons or placed the electrons on these shells and subshells. So, for example, if we look at beryllium you can find here on your periodic table, you see its atomic number is 4. That means altogether it has 4 electrons. So, you know that your first shell is so that first main shell 1, will have an S shell, and that can go up to 2 electrons. Yep, that's a 2. And then we also are going to add on a second shell, so we've only used 2 electrons so far, we need 2 more. So the next shell out is that 2s, which also can house those final 2 electrons. So that should hopefully make sense, because then if you add up 2 plus 2, that means that so far there's a total of 4 electrons for that atom. So another really easy way to do this, that I like to use personally, is just using the periodic table as a map and reading across. So, let's try this out. Fluorine. We find it down here. There's 9 electrons. But let's read across. So the first thing, we'll start in the very top row or period, and we're going to use up 1s, 1, and 2. So if we come down here, write that in, 1s2. The next step is popping down here. So we'll use up these two, and that's our 2s2. And then you would just continue over to this side. So this is 2p, your 2p row, and fluorine is number 1, 2, 3, 4, 5 in that row. So 2p5. And it's that easy. And then if you add those up, 5 plus 2 plus 2, you have your total of 9 electrons, so that should hopefully make sense then. So if we do vanadium, which is down here in the transition metals, so we got to go a little bit further now. And don't forget, you can use your electron or your noble gas configuration. So let's try that out. So the last noble gas before that is argon. And then next after argon, we come down to 4s. So you have your 4s2. And then remember that this is actually 3 for the D block. It sort of skips up one, so 3d3 is your final one for that. So that's your configuration for vanadium.